Hi everyone, my name is Mike Emblin. I'm a product support engineer for Bell. I'm here today to do this virtual presentation, and we'll be talking about for the next hour or so, we'll be covering the medium helicopter technical briefing. During that time, we'll be starting off with a bit of the PSC team update, moving into some fleet status information. So fleet status is like we'll cover the hour leaders for 204 aircraft through to the 412 EPI models. Afterwards, we'll roll into service directives, talk about most recently released ASBs and the stories behind those. After the ASBs, we'll roll into maintenance and field issues. For these presentations, we do our best to make them as relevant as possible to the audience. So we cover topics that we at PSC receive questions on a recurrent basis. So in there, you might see stuff that is relevant to you, or you might see stuff that might seem dated, but it is still very current as to what we see ongoing. After that, we have a specific section on 412 EPI and EPX. And there's some interesting stuff in there because we'll cover some of the technical aspects of the EPX and how they're different from a 412 EP or even EPI. And to end off, product improvements, we'll cover some of the upcoming changes or improvements to these aircraft. And questions, being a virtual event, we'll save the questions for the end of the session. And we're gonna be covering lots of materials. So throughout the presentation, because questions are at the end, which is a bit different, usually we have them live, I would suggest to take notes and write down what your questions will be and save them for the end. That way we'll do our best to answer them. All right, so what we're seeing here is a list of the team members on the PSC team, the medium aircraft team only. What's interesting is it's a team made up of a lot of different folks from various backgrounds. So in part of the team will have ex-aircraft maintenance engineers that worked in the field, like myself, but we'll also have folks with a manufacturing background, which all of this together creates a good team that can really support a lot of the questions that come in. We also have focused on avionics and airframe practices to really make sure that the questions get answered as precisely as possible. What's new too, or relatively new, is we have a product support engineering team set up in Singapore. Now we have 3 team members working there. So they cover the 12 hours or the off hours that we're not covering in Mirabel, Canada. Also, a bit of a structure change is we have dedicated product support engineers to the actual aircraft programs or products. And what that does is really helps address issues and long-term snags that we are trying to fix from an engineering standpoint. And so far that's proven to be helpful, and we think that that's going to be the status quo moving forward. Okay, so how do you reach product support? A couple ways, either one is fine. You can call us or you can email us, but we've recently made emailing even easier with going to a single email address. That address is up on the screen, productsupport@bellflight.com. Something to note is the fact that the size limit for incoming emails is 20 megs. So if you're going to be sending high def video or pictures, just keep in mind of that 20 meg size limit, because then if it's beyond that, we will not see it. The system we use is going to generate automatically. When you send us an email, don't be surprised if you see a reply almost instantaneously, because it's an automated email generated by our system to capture and not lose any information. And in that email, you'll see a reference ID as well as a case number. So it's important for continuous discussion afterwards, back and forth emails, do not delete those numbers, because that's what helps us track everything. Phone number is listed there on the screen. And if you want more information on how to reach us, you can always refer to an information letter, Gen 19-145. So as I mentioned, the fleet status up on the screen, 204B and 205A1. So not many 204s left, about 21 in its high time, 33,000 hours. Roughly the same high time for 205, 33,000, but many more active aircraft, in that case, 166. 212 and 412. 412 EP, I should say, because we have a separate slide for EPI only. 212 being 500, approximately 509 aircraft still active, and the 212 is actually the highest airframe medium we have, is sitting at 41,000 hours. The 412 being 26,000. And all this information in the presentation will be given to you as a PDF format. So, you know, if any of this stuff interests you, I don't want to sit here and read the slides because we have a lot of information to cover, but rest assured you will get a PDF copy of this afterwards. And EPI active 54 currently, and its high time is 6,200 hours. The high time ship is an EPI that's been converted via STC. Okay, moving on to service directives. In this section, we'll talk about recently released service directives or revised service directives, and for this presentation's sake, it's all related to alert service bulletins. First thing, though, that we feel is really important to mention at all these conferences is the fact that in order to have the most current and recent information when Bell releases bulletins, it's really important to visit the bellcustomer.com website. That is the place where any service directive, whether it be a tech bulletin or an alert service bulletin, something more urgent, is posted first. The best way to keep current on what's being posted, because you don't want to visit that, you know, if you don't have to, is you can subscribe to the email system. So as soon as we post something, you'll get a notification via email, and you can choose any email address. You can enter a Hotmail, Gmail, a Yahoo account. It doesn't have to be a vetted email address as a contact through our system. So any email address will work. And that way, as soon as we post an ASB, if it has a short compliance time and you have to take action on it, you'll have the information as soon as we've released it. We say that because there might be, depending on how things line up, a certain delay between when we issue an ASB and when it gets posted to the technical publications website, which is account-based, password required, and so on. So to make sure you're not going to get affected by those delays or difference of posting dates, we suggest getting in touch with this bellcustomer.com website. And again, you don't need, for this one here, customer.com, you don't need an account, you don't need a password, it's available to all. Okay, so this first ASB is something that is affecting oil and fuel check valves. The part numbers are there on the screen. This first started with an ASB back in 2015. And then as the information came in and we had more reports of valves outside of the initial batch of affected units started coming in, we had to issue another ASB to address the issue again. So in most recent events, to try and summarize all of this, what we're looking at are check valves, oil and fuel check valves that are found throughout these aircraft. And if you see on the screen, those red circles by the model of the 412, that's the approximate location of these valves. And what we're worried about is the potential of having a cracked valve. Okay, so this was discovered years ago when the maintainer was investigating an oil leak, and he traced it back to a oil check valve that the body was cracked, like you can see there on the presentation. Following that cracked valve, the vendor researched and figured out with the help of our QA that during assembly, some valves may have been over tightened, causing strain on the valve body, and then with time in service, vibrations, and so on, could lead to a crack. Now it was narrowed down to recently to valves made at the from Circor Aerospace only, for one. That's the only vendor that's affected, and the only facility that the vendor has mentioned that these valves are coming out of is the Corona, California facility. Okay. The other thing to mention is the marking TQL, which has led to some confusion. TQL is the marking on the valve that the vendor has chosen to identify which valves were made with the revised torquing procedure. So if you have a valve marked TQL, you're not affected because that's implying that the valve has been assembled using the revised torquing methods. However, this TQL was introduced in 2015 following that initial ASB, okay? So stay with me here because most recent revision of this current ASB states that if you have a valve with a date stamp 2015 or post, so 2015 and up, and you don't have TQL, you're still okay. So all that is well written in the ASB's lengthy description. And if you have any further questions on any of that, I would suggest going and studying that ASB because there has been quite a few changes over time and through revisions. Up next is an ASB on the tail boom left-hand vertical fin spar cap. Vertical fin spar cap is self-explanatory as to where it is on the aircraft, and if you're not familiar, it's shown there as the red circle on the 412 model on the screen. This is an ASB affecting 205s, 212s, 412s. How this came about, there was a customer performing routine maintenance on his aircraft, and he found some crinkled skin, smoking rivets. Something wasn't right in the tail section of his aircraft. And upon further visual inspection, found that the spar cap was actually cracked, which is what you see on the screen, bottom right-hand side. That should not have a gap that is shown there. That is a cracked fin spar cap. So it was a isolated event, but nonetheless, we felt the need to address this because via ASB, because what we want is we definitely want maintainers and operators to focus and inspect these areas. So what the ASB mandates is a recurring visual inspection using a 10x magnifying glass. And you're going to be doing this every 100 hours, and you're basically looking for cracks, loose rivets, or distortion. And since the release of that ASB, we have now included these inspections in the 412 maintenance manual as of January 2021. So it's really just an effort to make sure that these areas of this aircraft are being inspected on a regular basis. Next is a very recently released ASB on the 412 only. This is a ASB on the 412 tail rotor drive shaft. What happened was a customer was doing some maintenance on their aircraft, and upon visual inspection, they found on the inner diameter of their tail rotor shaft what appeared to be a defect or paint peeling or something going on underneath the outer flange, which is what you can see what they saw on the top right-hand side, some defect in between the rivets. So we weren't too sure what that was, and we felt the need to investigate further, so we got the part sent back to our field investigation lab. And at that time, in the bottom of the picture with the blue background, you can see the parts were taken apart, and you can see the amount of corrosion underneath in the actual tube itself. So the cause of the defect visually was the corrosion. It was definitely corrosion, and a QA investigation then ensued, and it was found that during manufacturing, a total of 4 shafts, so luckily it's just an isolated case, not very many were affected, but a total of 4 shafts during manufacturing in around 1999 timeframe, there was a lack of primer installed. There should be primer installed in those areas when they're put together, but 4 shafts in 1999, for some reason, did not have sufficient primer. So this ASB was released to go and capture all of those, and you have to initially look at the serial numbers to see if you're one of the shafts affected, and if you are, you have to remove it from service. Okay, so that's it for ASBs on this presentation, but after this, we're going to move into maintenance and field issues. Okay, first up, what we're looking at here on the screen is a main transmission support case. Now, over many years, we've had occasional reports of cracking at the lugs of these support cases. And upon further investigation recently, we had some of these sent into the lab. We had the opportunity to get some sent into our lab to investigate really what is the root cause and why do these crack. Well, it was discovered that most of these failures are due to corrosion under the wear plates or the big washers at the corners of the mounts, at the corner mounts. We did release an information letter on this that if you want the more in-depth write-up, you can go ahead and read that information letter 212-2071, or they're all listed there. But what came about this, we figured that we had to introduce and make some changes to try and mitigate or reduce the risk of having cracks at those corner mounts on these support cases. So what we did is we did a couple things. We introduced a new inspection, which is required at 3,000 hour special inspection and the 6,000 hour transmission overhaul. And in a nutshell, what you're doing is now we finally have instructions to remove the top and bottom washers. And by doing that, now you'll have a better view of what's going on under those washers and whether or not you have corrosion starting to affect your part. So here's a good example of what can be found. Because we never had a procedure or anything previous to this to actually go and look into this. Now we have procedures to remove the washers, a new way to install them using primer and sealant once you finish your inspection. But during your inspection, now the manuals have been updated to include damage limits. So it's not, confusing for anybody. You take it apart, you know what you're dealing with, and you can really determine whether or not your parts are going to be repairable or serviceable. What we found is most of the time the cracks are from one of the three washer retention screw holes. As you can see, seems to be the focal point of the corrosion on this picture. And we'll see cracks start from there. The reinstallation of these has been changed, but also during manufacturing, when we initially put these together currently, the engineering has been changed. So now when we install the washers, we install with primer and with sealant around the outside diameter and inside diameter to really make sure this joint is not going to have corrosion as it does in the past. So staying on the topic of transmission mounts, I'll give a bit of background on why we made some changes here on the actual airframe corner mounts. Not talking about the transmission support case anymore, but more about the actual airframe corner mounts and the friction dampers themselves. So in 2018, there was an operational safety notice issued to address an unwanted dynamic situation in the 412. And what it described was mostly to make aircrew aware of certain situations that may occur when operating a 412. Is, in a nutshell, you could enter a situation where if you have for example, one skid touching and a large forward cyclic movement at the same time, all these factors together, you could end up with a large vertical 1 per rev vibration, okay? And so that's from an aircraft operation standpoint, but from a maintenance side, we found that the chance of this happening can be greatly reduced if you have transmission corner mounts and friction dampers in very good condition. And these are parts that are often overlooked. So we introduced a specific inspection each 3,000 hours of transmission and 6,000 hour overhaul that we're going to be going and inspecting these mounts and friction dampers on a regular basis. Again, more information about all this in an information letter 412-2088. So up next here, we're talking about tear-rotor drive outer couplings. And these are on the 212, 205 style and 412 Classic. So we're not talking about HP aircraft and up. And we just want to raise awareness that in recent part deliveries, some customers have received these couplings and thought they were defective. And what they were talking about is the left-hand side of this. So we have two different couplings here, same part number, but you can see there's a difference in the aft lip. What we're all used to seeing, most common way of manufacture is the right-hand side, but the aft lip is cut. The left-hand side is simply the same part number, but it's simply a different method of manufacturing. Both versions are acceptable to engineering, and there's no difference in functionality. So if you do have one that's not cut, that lip is not cut, it is simply a different method of manufacturing that is approved. The difference being one is made using a broach, machine tool called a broach, and the other one is the splines are cut using a shaper. That is simply the difference. I will note, however, that some feedback we have received is that the couplings with the lip that is not cut, they have a more difficult time installing that orange grease seal. It just takes a bit more time and finesse to get it to properly sit in there. Okay, onto some tail rotor blade inspections, and more specifically the leak check. So leak checking a tail rotor blade is something that has been in the books for some time, but not everybody was aware, and this was brought to our attention recently. So we figured we would raise awareness and talk about it a little bit. So what is a leak check? Essentially, the leak check is going to take your bare blade and you're going to dump it in a tank of water set to a certain temperature, and you're going to inspect for air bubbles leaking out. Why do we want to do a leak check? Well, we want to make sure that you're not going to have any debonding or separation at the bond lines. That's because if you have that and it's left like that for a time in service, you may end up with water and moisture ingress, which will then have corrosion inside the core, and all these things are just not favorable for these tail rotor blades. So you're going to do a leak check if you have signs of delamination or separation, especially along the bond lines. Or another thing too we've seen is if customers are troubleshooting odd vibrations and they can't seem to isolate why it's occurring, you may want to do a leak check because maybe one of the bond lines has been separated for a while and moisture got in there and now your blade is compromised. Something to note is blades that do fail leak checks are to be removed from service and they're non-repairable. So in an effort to reduce the amount of scrap blades or needlessly scrap blades, we made an effort to better judge a pass or fail of a leak test. And what I mean by that is we rewrote how to judge the bubbles versus time coming out. So when you dunk a blade, the limit now is less than 1 bubble for every 5 seconds from a single source. So what I mean is occasional bubbles, throughout the blade when you're dunking it is not a cause for rejection. Another thing too, to try and salvage some of these parts, crack repair instructions have been improved. So repair materials offering more physical flexibility are now being used. The maintenance manual in this case used to say a steady stream of bubbles, but now we have it more black and white and more specific, something that's more measurable and not so up to interpretation. This is just a bit of a good news change. Something that we always like to do when we can is push inspections to the right when we don't want to aimlessly do maintenance. So what we're talking about is the actual collective pilot's collective stick inspection. So we used to have a 5,000 hour 5-year, used to be part of the 5,000 hour 5-year inspection. However, some field evaluation proved that we could extend this inspection now. Instead of being part of that 5,000 5-year, it is now just every 10 years. So that's just something we want to talk about, and we always like, sharing those good news stories. Okay, so here's a very popular question that PSC gets on the medium. So what we're looking at in the picture is swash plate support, collective sleeve, but what I want to talk about is the actual collective lever itself and the lateral play. So we get calls, we get emails saying, hey, I was doing some visual inspection or doing a DI and I noticed that I have some lateral play or what's referred to as lateral chuck of the collective lever, and is this okay or not? So if you look at the engineering and how this thing's all put together, by design, you will most likely have from day one a 12 to 21 thou amount of play there. So it is normal to have 20 thou lateral play. This is not something that is alarming. And what we have in there also are these bushings that the flange face has a Teflon liner, which is 20 thou. With time and service, this Teflon liner will wear, and as it wears, well, it's common sense, you'll have more of that lateral play in the collective lever. What's good or not good? If the Teflon liner is so worn that you're starting to see metal coming through, meaning the Teflon liner is no longer fully covering the face of that bushing, you have to do some maintenance. You got to replace those. So that covers. If you have further questions and you still have doubts about how this is all put together and you want to talk to us, we're always available, phone call or email, and we'll be happy to help you out. Another hot topic is the 212 and 412 tail rotor pitch horns and the pitch links, as you can see on the screen. So there are a lot of seemingly tech bulletins and changes and configuration relationships between which pitch link to use and which pitch horn, and the generations have changed, and it is difficult to track and keep tabs on what's okay and what's not. So for those that don't know, on the mediums, we have adjustable pitch links that are available and non-adjustable pitch links. The thing is, depending on which pitch link you're using, you're going to have to use a certain pitch horn. Okay, and as you can see in the description of the slide, there's a lot of part numbers there, and I don't expect anybody to memorize this at all. So it's very important to brush up on the tech bulletins and the configurations that are approved. But what I want the takeaway of this to be, for the sake of this presentation, is that on your tail rotor hub assembly, you're going to have both pitch horns are going to be the same part number, as well as both pitch lengths. You can't mix and match. So that's, at least, if we could take away something from this, that would be something. And just to raise awareness that maybe if you have doubts, if you're within configuration, this is a good slide to remind you to go and check if you have the correct pitch horn to pitch link relationship. So moving on to a bit of a headache for folks in the field is sometimes the tail rotor gearbox will leak from the crosshead area, as can be seen in the picture. So we get enough of these questions that we figured we'd make a couple slides on what we've seen can sometimes fix this. And we'll start off by saying which ones most commonly repaired and some oddball issues that if the easy fix hasn't stopped a leak, then maybe you can go dig further. So first off, though, this is a leak that will occur dynamically, and what's happening is oil is migrating between the pitch change rod and the output shaft. So if you do have this, the leaking will be found, you'll have oil weeping from the retention nut dust boot. As you can see in the picture, the bottom picture kind of zoomed in the circle there is the dust boot has been removed, and you can see oil is weeping out. So several factors, but first we'll address the most common causes of that leak from the crosshead. The most common being the gearbox is simply over-serviced. If you rely on the sight glass, which is very common and very normal, you can end up in a situation where the gearbox has been over-serviced, because that sight glass is very sensitive to aircraft. You know, if it's parked, and these helicopters, being helicopters, they park on uneven ground, and if they're nose down, nose up, or left to right, that sight glass oil level will be affected, and you may end up over-servicing it over time. If you have doubts, I would suggest draining the oil completely and fill the gearbox, not relying on the sight glass, but using a measured amount as required from the manufacturer's data, which in this case is 0.4 US quarts or 0.38 liters. So that's the first thing to do, is to drain everything and fill it to a measured amount and see if you still have this problem. The other common thing, for those that don't know, the oil caps on these gearboxes are also acting as a vent. So you want to make sure that the cap is doing its job, is not obstructed, and if you want, you can take these all apart, make sure the oil separation, air oil separation material, it's a, you know, kind of like a wire mesh, is in good shape. Clean it up, put it back together, and that's another thing that you can make sure is we want the gearbox to vent, to breathe, and if it can't, well, then oil is going to find its way out. Some less common causes. So on the pitch change rod, remember I said the oil is going to migrate in between the output shaft and the pitch change rod, which runs through the output shaft. So that pitch change rod has cork stoppers that are sealed on each end. And it's rare, but we have seen this, that if one of the corks is not sealed, with the pedal motion during flight, that can act as a pump and wants to drag oil out from the gearbox behind that bearing section, and it'll travel along the shaft because it's trying to pump it into itself. So however rare, if you're running out of ideas on how to fix this, you may want to check that those corks are in fact sealed. The other thing, the last thing, is in that picture right here on the bottom, there's a cutaway of the gearbox. And at the back, what we're pointing to is the duplex bearing. If that duplex bearing, for some reason, maybe it's built on the close, maybe the cage is very tight, maybe it's a PMA part, who knows, but the oil by design is supposed to flow back through the cage and the bearing and back into the sump. If for some reason that bearing is not letting that happen, you can have oil pool up higher than what it's supposed to do, and then as it pools up higher, it has nowhere else to go except down the output shaft in between the pitch change rod and that output shaft. So those are the things that we have seen can cause this. So if you have an aircraft that's experienced, having this leak, these are things you might want to try. Okay, a bit on the 412 fuel system. We'll talk a bit about the 412 fuel system, the 10-cell system. Now, as you can see in the picture, there is a lot going on, and we could essentially have an entire breakout presentation on just the fuel system. So that's not the intention here, but I want to touch base on, one of the common snags or headaches that is pretty popular in email or phone call to PSC that we get. So in a nutshell, though, first, the 412 fuel system, specifically the 10-cell. It has a couple functionalities, but all of the intention is, whether it's the different standpipes, the different heights of the standpipes, the transfer pumps, the thermistors. Thermistors are what's in the system to tell you where fuel is, to tell the system where fuel is and how to manage it. All of this plays in the burn rates. Everything is played in to make sure the aircraft during operation, it's seamless and it doesn't affect the aircraft CFG. So everything has the different burn rates, which is what you can see there in the upper right-hand side is what we're trying to show. But what I want to talk about now is if you have fuel snag in the field, and this may seem, redundant, but the best thing you can do, and it's what I would do if I would, because it's not something we look into very often, is in this case, the 412 maintenance manual, chapter 28, 96, and 98, they all have very good write-ups and very good descriptions on how this fuel system works, what's the order of things, where's fuel being pumped and when, and knowing that and knowing how all these parts work together after reading the description is really going to help you troubleshoot better and narrow down. Instead of shotgun troubleshoot, you really have a better idea of how the system works, and just with that, you'll be better equipped to troubleshoot. But what we will address is a bit of the fuel transfer light snag. In a perfect world, that fuel transfer light should never come on, in a perfect world. However, it can, and if it does, it could be caused, a couple of factors. But when will a fuel transfer light come on? Well, the system is not going to be happy, and it's going to flag you fuel transfer, basically saying fuel transfer is not functioning. Is you have thermistors in the cells that tell the aircraft or tell the system there's fuel remaining or there's no fuel left, and those thermistors are controlling or triggering the transfer pumps themselves. Transfer pumps are moving fuel from the forward cells back to the cells that are actually being drained to burn or to supply the powertrain, the engines. So you'll have there's many factors why you'd have a fuel transfer light come on, but briefly, if you don't have if the system's not seeing any flow of fuel through a flow switch check valve, and the thermistors are reading that, hey, I still have fuel in these forward and mid tanks, then I'm going to trigger a number 1 or number 2 fuel transfer light, because it's sensing that something's not right. But here is a good list of, and a good example of why you're going to want to study the system. Fuel transfer light could be transfer pump, thermistors, the switch check valve, the signal conditioner, and on and on and on. You can read those. So understanding the system and going to the easiest things first is really going to help isolate and make your life easier. We do have some very, very knowledgeable people at product support in Mirabel on the 412 fuel system. So if you're in the field and you're stuck and you're running out of ideas, out of time, feel free to call us, email us, and we do have some very, very good folks on this 412 fuel system. Lastly, on this topic is something that came into us recently, and you can see in the pictures it doesn't look pretty. What we're looking at is something that I didn't think could happen, but it did, and this is unfortunate. But what happened was the self-sealing fuel cells on these medium aircraft, in this case, there was a tear of the inner surface and it went unnoticed. What happened was it absorbed and started swelling with the fuel in there, and essentially contaminated the whole fuel system. So it went through the engine-driven fuel pump, the fuel filter was contaminated, and it created a huge mess. So it's something we just wanted to share, and when you are doing inspections of these fuel cells, to pay attention, because this is a mess you don't want to run into. Okay, now specifically on EPI and EPX. For those that don't know, an EPI is a 412 EP with some modifications. For example, you can see the difference in the cockpit view right there. You have 4 6 by 8 inch multifunction display units. It's dual channel ADIU, and the actual power plant is a T9 twin pack with electronic fuel control. So it goes away from the pneumatic AFCU, MFCU controlled systems, which were known and famous for having issues like torque splits and trying to get them to run together perfectly. So this new electronic fuel control system on the T9 goes away from all that and fixes a lot of those snags. The EPX just takes it a couple steps further. And for those that are interested, the serial number ranges on the EPI are 37,000 and up, and EPX is 39 and 38 and up. So those are the serial number ranges to identify EPI versus EPX. The EPX is an EPI with a transmission and mast upgrade and an avionics update. So that basically is an EPX. I'm not going to go through everything on that slide right here, but I will mention that the main rotor gearbox, very interesting, is now has a loss of lubrication capability. So that's a huge change on these aircraft. You have increased gross weight and enhanced hover performance. Functionality is now basic, and there's some other things. But what I want to do and focus on for the sake of this presentation is more into the technical side and technical aspects of what do we mean when we've changed the loss of lubrication, and how do we get there. So that's where I'm going to go with this here. You'll see here's a picture of that EPX transmission, the top case portion. So how did Bell do it? How did we do it? Well, the engineers installed an external oil reservoir on the top case of this transmission, and with that there's a little drip system for the planetaries. Okay, and that one oil will drip through. So in the event that you have a burst line or an issue with the sump itself, you lose your oil during operation, that external oil reservoir has proved to be able to allow this aircraft to run for an additional 30 minutes at least without any issue. With that, the actual sump has been increased too, so you actually just also do have more oil. In order to withstand the heat and the stresses of a loss of lubrication event, there also has been some changes made to current design. So in this screen here, what you see in red is what's been modified, and what's in blue is what's completely been added. So like I said, in blue there, as you see a cutaway of the tank, transfer tube, and a drip nozzle. You can see the nozzle pointing right at the top of planetaries. And what's in red is just been modified, so you can see the pattern is these planetaries, the gears, the bearings. All these items have been changed or modified to really withstand the stresses and the heats of a loss of lubrication event. Also on the EPX, there's been some improvements made to the mast. A couple things. So because the aircraft is going to be operating at a higher torque rating, so we had to change the main rotor hub spline width. So that's to compensate the increased mast torque. At the same time, change the plating from CAD plating to zinc nickel. Zinc nickel is just something that's actually replacing a lot of CAD plating on our components. So because this part was being revised or designed with some changes, we figured we would also change the CAD plating to zinc nickel. We went from a bonded wear sleeve to a tungsten carbide coating. This was to reduce the corrosion in that area. And also a big one, which a lot of us are familiar with, is the mast seal leaking. But in this case, on the EPX, not only the seal was revised, but that whole retention plate has been modified to reduce the chance of having a mast seal leak. And so far, so good on the aircraft that are out flying around with this. The biggest change and the most simple change to understand how this leak was, how the mast seal leak has been fixed was in this picture. You see the mast seal and then the little blue passage there, the cutaway passage. That is essentially an oil drain. So whatever oil can't find its way back through the duplex bearing will find its way back to the transmission, not outside, leaking down the top case, but internally through passages. So again, here's cutaway the old versus the new. On the right-hand side, you'll see the cutaway showing a lot more room and a oil drain. So closer view, just everything's been done and taking into consideration to really stop any leaking from that area. And like I said, so far the feedback we've gotten from the aircraft, the demo aircraft we have in the field flying around, has been successful. So along with changes to the mast, well, you also have to change the mating part, the main rotor hub. So the spline plate, the upper cone seat, and the lower cone seat, they all have been changed due to the increased mast torque of that aircraft. We also changed on the EPX, went from a electromechanical standby attitude, altimeter, and airspeed to a MD302 standby attitude module. So it takes up less real estate. It's digital. It seems to be the trend that we're going with these days. From a maintenance side, EPI aircraft or digital aircraft in general, you're going to now deal with software and how to communicate. Now we're going to have laptops. From a maintenance standpoint, laptops communicating with these aircraft. Well, the laptop software is going to have to align with the aircraft software version. If these aren't communicating properly because of software differences, one is designed to work with a certain one, you may end up with some odd situations like we see here. So on the right-hand side, we see a laptop screen showing engine 1 and 2 starts at 0 and 12. And on the left is the actual aircraft showing the starts at 39 and 38. So you can see the miscommunication, and this was caused because the DIMIT software, which is the laptop software, was not the correct version to communicate with that aircraft's current software version. So just something to keep in mind if you're having some snags between your ground-based equipment and your aircraft. Just check the software versions and make sure they're what they should be. Something to mention too, because of the recent change of actual displays, we went from an RK display to an ACA. Well, along with that, you're going to have different DIMITs box, ground support equipment. So you have a different DIMITs switch box, cables, and software as well. So it's just, it's all documented, but we want to raise awareness to folks if they're going to have these aircraft in the field. So if you're having strange electrical avionics snags, we have found that a lot of them can be traced back to the signal distribution modules in the EPI EPX aircraft. So these SDMs are located in the nose of the aircraft. They are susceptible to water infiltration, moisture ingress, being based on their location. But what we've seen too is possibly during maintenance, somebody reaches in and leans up on those connectors, displaces them just enough to have intermittent snags and some really strange faults. So that's a good place to start looking if you're having, to troubleshoot an electrical snag. Here's a good picture of a connector that's been dislodged. You want to make sure connectors are fully engaged and locked into their receptacles. The 412 EPI, our avionics guys wanted to share this with folks because they have seen some events of fuel transfer cast message lights coming on, and quite simply they have narrowed it down to that this is an indication of low bus voltage. So try starting with a GPU, and if you don't have this anymore, this problem anymore, then your battery may need service. So hydraulic fluid on the EPI and the EPX is actually different, and it was certified using a different fluid. So here's a topic of discussion where if you have a mixed fleet, you have a bunch of EPs, and then you start getting some EPIs or EPX. If you have a hydraulic mule in the hangar with 5606, very important, you cannot hook that up or use that with your EPI or EPX. The reason you can't change the fluids around on the EPI is because it was certified using the fire-resistant synthetic fluid. Okay, and by doing that, the hydraulic high temp limit has also been increased from 88 degrees to 115 degrees. So you can see you can't go back to the 5606, not only because it wasn't certified like that, but the high temp limit has been increased based on the fact that it was certified using the higher temp fluid. Versus the EPI, the EP, you can use either or fluid. Okay, so the final section of the presentation is the product improvements. What we're looking at here is a project that's been that Bell has been assisting with. It is an STC installation by Cayman. It is a K-Flex drive shaft installation on 212 and 412 main drive shafts. The couple things are going to have to happen in order for you to, if you're interested in this kit. Bell recently released and tested actually is the service instruction 99, and what that service instruction is a firewall mod, because you have to modify the firewalls in order to fit this new K-Flex shaft. The K-Flex drive shaft is an interesting option. It has a 5,000 hour TBO with a return to Cayman for refurbishment requirement. But in between that time, there's reduced operating cost and no downtime. You don't have any couplings to re-grease. You don't have anything beyond a simple visual inspection on the helicopter. That's all you need. You don't have any need for removal. So this is a very interesting option for folks that might be looking for a way to get away from, greasable couplings. And here is some pictures of that service instruction I was talking about that has to be accomplished in conjunction with that K-Flex drive shaft installation. It's pretty involved. You're going to be modifying the forward firewall, center firewall, and the left and right hand intake cowlings. Approximately 60 man hours to accomplish. However, depending on experience and equipment available, it might be reduced substantially. So just keep in mind, this is going to be a requirement as part of that kit. There is a new collective lever for the 412 introduced by Tech Fulton 41220-244. This is really interesting and has quite a few advantages in the sense that you have a lever now with a 20,000 hour retirement life and no penalties. So whether you have strake and fast spin, slope landing, increased gross weight, any of those things, you're not going to be impacting the life of this collective lever. So that's good news and makes it easy to track. Like I said, the TB has been published, released. With that, you'll have to require the most current or later configuration hub and sleeves. So anything after 412, 010, 401, 115 will be required. And you can refer to a TV to upgrade to that number if this is something you want to eventually install. You're also going to need new attaching parts, pins and shims. And another interesting point is with this new lever, you will no longer have a recurring 100-hour special inspection. So here's a picture of a crew barrier kit is what it's called. This was, designed and introduced as demand was for the in response to the COVID-19 pandemic. So there had to be a way to isolate crew versus the passengers and to limit the transmission of these airborne contagions. So it's a super simple kit. As you can see, it's held in with Velcro and it does a good job. It does as it's intended. And it's available, for those that didn't know, through Aeronautical Accessories. And in fact, it's an Alpine Aerotech STC. Okay, so a bit on Bell Mission Link. So Bell Mission Link is something that it's a website. It's a website it's Bell designed, owned, made for aircraft that are equipped with the Bell Helicopter Vibration Monitoring System, which is our version of HUMS. HUMS is a health usage monitoring system for aircraft. BHBM, you're going to have a ton of sensors, a ton of data coming in on your aircraft with vibration related data that you can have. You need a way to understand and read all of this information as it's being gathered on your aircraft. So Bell Mission Link is a website that is available to customers that have these Bell BHBM systems. We used to use, for those that know, we used to use the Honeywell web server. However, that's been discontinued, and now it's a Bell managed system. So a bit on what that means. So here are some screenshots. Might be hard to see, but Bell went with a really user-friendly layout and interface. So it was very straightforward and easy to read vibration information and data as it was coming in, as you upload it to the system. You can adjust thresholds. And also what's very neat is the data appears on the actual server within 5 minutes of uploading. So it's very fast and very quick to get new data. Something that's really worth noting too is a functionality that product support pushed heavily for during development was, say you are managing your fleet of aircraft that have this BHBM kit and you're reviewing a certain specific vibration and you drill down into the graphs and the charts and you're not sure if you're interpreting it properly, or you even want a second opinion, third opinion. You can drill down into this website or exceedance through this website and get to a point where you literally click a button on the website and it'll automatically create a product support ticket that will then be channeled to the HUMS support team. So it's a super cool feature. You don't have to email it. You just click the button and all the information relevant to that exceedance is already populated. You don't have to fill anything in, and product support has the HUMS support team will have been made aware of it, and they'll get in touch with you with their feedback regarding that exceedance. Very powerful tool, and as folks get used to it and used to using that, it's going to be, we think is something that is going to be very popular. If interested, the BHBM kits are available through Aeronautical Accessories. Lastly, on the API, we do have a display unit retrofit kit, and essentially we're going from arcade to ACA units. They're higher resolution displays, and also will essentially reduce some weight as well. But the kit, for those that weren't aware, is published and is Service Instruction 100. So that covers my portion of this event. I really appreciate everybody joining in. And I realize we covered a lot of material, but if you do have any questions or anything you want to discuss, always feel free to call us or email us, and we'll be we'll be happy to reach out. Thank you.